rely on the balloons that come with the tank if you ever do this. So we've got helium in here. We want more CO2 and water vapor to buoyant it. And I'll tell you, if these things ever pop, there's going to be somebody that'll get really mad at you because they are loud. Okay, so how does oxygen bond together? It's got a double bond in O2, right? So we'll at least call it a covalent bond. So we're still a little heavy, but that's okay. Watch this now. I'm afraid if this pops, I'll blow it. I'm going to show you the good one first, since we're blowing these around. Let's try one more green one. It's not going to happen. Okay, let's do this. Where's my other green one? This is the beauty of this too. The velcro. When you go to your office supply part of, I hate to give Walmart a free plug, but it's cheap. They got everything right there. You got the dot ones. And thanks to the 3M chemists, these things stick really good. So since I'm on the fly with this, there's two kinds of the velcro. You got the little hook part and the fluffy part, right? So if you're a real chemist, you can even take this to the point where these are orbital, anti-orbital kinds of things. So when you go up, it won't bond, right? So this one has the fluffy, so I got to get the spike part on it. So put the spike part on. It sticks. It's a little buoyant. So this is why I'm so enthralled, but I'm enthusiastic about it. I'm at space camp. I've got all these kids out there. I tell them, this is, anybody know what, if this is our oxygen, do you know what molecule that would represent? Ozone. Another one of our greenhouse gases with the green theme, right? So I'm telling the kids, got the whiteboard and all this, ozone. O2 is what we breathe. I tell a joke. Anybody know what H2O is? It's water. What's H2O for? It's for drinking. So then I ask the kids, what's O2? Oxygen. And what's O2 for? It's for breathing. So you've got oxygen to talk about, and then you've got your ozone to talk about. So what I did was I took the ozone, we had a high ceiling, I just threw it out there. Is that one going to float? It's not perfectly buoyant. But what it does, it goes up beyond what the kids can reach. So I let them try and reach it. They're standing on the chairs and they're trying to hit it. They're all laughing and giggling, so they're getting that energy out, but they can't reach it. So then you got them, right? Because they're waiting. They're waiting for the balloon to come down. You go over to the board. What's this thing doing? You got them at the board. And when they're bored with you, they're looking at the balloon, but you got them for like 3-4 minutes, everything. So O2 and then your O3. This is chemistry, right? The bonds are electrons between these. So we tied the two O2s together. That's going to be a strong double sigma bond, whatever you want to call it. But this third one, how does the ozone absorb the ultraviolet ray? You can do the drawings in H mu, you know, and all this, but it's not this. What I did was, I swear this worked the first time, this is why it was so cool. It was floating around, and I'm going on, and I'm drawing the picture of the Earth, and how thin the atmosphere is, and everything else. See, we call that breaking bonds, right? And it was a green one. Oh, that makes me mad. You're going to have to really use your imagination here, because I want to show you how this works. It's going to be red. We'll make it yellow. So the point is, when the molecule finally came low to the ground, not even low, but the biggest guy, there's always a big guy that wants, you know, everybody's going to let him do it, right? So finally I go, all right, go ahead and do it. Stands on the chair, what's he do? Rears back and punches it as hard as he can. Guess what happens? Nothing. And I said, that's too high in energy. That's X-ray. And everybody's laughing, right? Because he's been waiting. They've been waiting 5 minutes. I mean, the power of the balloon, do not underestimate it. So picture this again as being O3. We got a covalent bond to the O2 here. it's too buoyant. So the first guy punches the heck out of it, doesn't break. The next little girl gets up there, punch it. Pretend your hand is electromagnetic radiation. Okay, too little of thing, right? Infrared gray. How about you? What's some of your frustration? See, it's too buoyant. I don't want to waste time trying to get this perfect here when I'm really in practice. Too low in energy again. How about you? Give it a hit. Too low in energy. I'll do it. How does ozone absorb ultraviolet radiation? The O2 stays together. But where did our little oxygen radical go? It's got a single electron on it. You see how this is really taking what's flattened on the paper and what we're trying to get them to memorize. But boy, when they are, I like the quote I came up with, that the kids are in the reaction vessel, right? I mean, the O2s are floating around. Oh, I'm sorry, I did not mean to do that. See, I told you, when it pops, there will be people that get really uptight about the popping. So, I want to show you the water. This was the other space. Anybody here into space and NASA education kind of stuff? Because again, the simplest reaction in that orange tank, it's great. O2 and H2 make, all that comes out of Space Shuttle's 3 main engines is water vapor. How am I running on time? So hydrogen gas, what's the structure for H2? Little single bonded, right? So we got 2 red ones. That's why I said red has got to be the positive one. We take our velcro. Since I'm so short on time and you seem enthusiastic, can you put one on one and one on the other and just connect it and make it? Or if one's going to float away or not. No, there. So make an H2 molecule for me. Usually on the other side of the nipple is the best place to put those. And we know as chemists that we're going to need twice as many H2s, right? So we're going to make another H2 molecule. And again, I'm sorry, I apologize. This is the most fundamental reaction there is. H2O2 to water. So, 2 O2s. Now what we need are the 2 H2s. We need O2s. Oh, and what are the books used for oxygen that I don't like? Usually red.
Yeah,
so
red and white for the hydrogens.
In nitrogen, blue. Someone said something like, in French, nitrogen kind of means blue. So blue and your amino acids, I mean, you can do amino acid chains with this I've done. What I want to do is, I'm down in Pismo Beach, is where I'm writing my books and stuff. They got the guy on the beach doing the long balloon things. So I got him working on making DNA, because you can do the strands and stuff like that, right? So we'll pick, just to make it colorful, let's say yellow for oxygen. Come on in, we're doing balloon molecules. I'm saying how easy it is to teach simple chemical reactions with balloons. She's smiling already. There's something magical about a balloon. Where'd that one go? Over there. Okay. So, I was saying what the power of the balloon is, you can do the size of the molecules in proportion. You've got color coding. Usually the velcro is so good a quality, this really sticks together. One more, can you get me? Okay. But see, people have fun with the balloons. Kind of did that on purpose. But laughing is contagious. You know, if we're teaching, we gotta have